Woohoo! Welcome back. Today, now that I've had my coffee, we're going to be talking about zero point 0.4 radicals, which is another word for what you probably know as square roots, and rational exponents. And what I'm going to be talking about in this section, I really hope is a review. It's perfectly fine if you're looking at these things going, whoa, I don't remember any of this. I'm really rusty. That's fine. That's why I include this in the class, because you will be using some of these concepts later on. So, but if you are finding that this is like brand new, doesn't feel familiar at all, I encourage you to come to my office hours, and I would love to go over all of this with you until it makes sense, or take advantage of the many tutoring opportunities we have. There are lots of wonderful tutors at this school, and they would love to help you out. So, having said that, I also have a note here that I have a very, very different way of approaching radicals, which I completely invented myself. It involves a very bad dad joke about bears, and basically it's the way I teach radicals. And if you didn't take my class for algebra, you may find it a little bit weird and unusual. And so I do encourage you to, if you're curious, go ahead and watch my video on bear math, which I've included in the playlist for you. So, having said that, I've got Square Bear here to help us with simplifying radicals. Yay! Let's simplify some radicals. So, again, if you know the traditional way and you feel comfortable with how to simplify radicals, go ahead and do it that way. I encourage you to use whatever method you already know. This is just the method I use in my classes. So what we do to begin with is if I hate this word, if the radicand, that's whatever's inside the radical, or the square root in layperson's terms. If it's really complicated, what I'll do is I'll set up a factor tree. So for example, 1800, I happen to know is 18 times 100. You might know it is 2 times 900, whatever, or 3 times 600. However you want to start off, there's a fact, fun math fact. No matter how you start factoring, by the time we get to the bottom and we get all the factors, all the prime factors, we will all get the same answer. Perhaps in a different order, but we will get the same number. So that's pretty cool. Doesn't matter how you start, we're going to end up in the same place. So 18, again, 3 times 6, or even 2 times 9, however you want to break these numbers up. And as you are factoring, it is common but not required. A lot of people like to circle the primes, so you know, okay, I'm done at that point. 100 is 10 times 10 in my mind, but it could be 2 times 50 or even 4 times 25. And let's see, 2 times 5, 2 times 5, and I will circle the primes. So this is how I start. I start by finding all of the prime factors of this number inside the square root, or the radical, or the principal square root, or the positive square root. There are lots of words for this little guy right there. So we're trying to figure out what times itself equals 1800. So how I'm going to start is to figure out what 1800 is to begin with. And I've got a bunch of these. I'm going to write them down, I hope, in descending order. I've got a pair of 5s, right like that. And then I've got a pair of 3s. And then I've got 3 2s. I might count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I got the same number. Hopefully I transferred it over properly. You could always check this by multiplying this out, making sure you get to 1800 again. Now, so far, everything I've done would be possibly something you do using traditional math techniques. Now, what I'm going to do is I'm going to say now this radical sign is now a cabin in the woods, and the Wi-Fi has gone out. And so all of you and your friends are trapped inside the cabin, and there's a hungry bear outside. Rawr, hence the bear math. And what you're going to do is you're going to run in pairs because this is a square root. No number up there means we're looking for the square root. What times itself gives you 1800, as opposed to, say, the cube root or the fourth root. This is a square root. So I'm going to take two numbers and they're going to go running. They're going to run through the forest. And the bear comes and eats one of them. And then those pair of fives ends up with 1 5, makes it out of the cabin, through the forest, and to safety. And I'm going to take a pair of threes. They go running. Comes and eats one of them, and so 1 makes it out. These twos, I'm going to take these two. Does not matter which two you take. They're going to go running. 1 makes it out. And now this 2 that's left over, it doesn't have a friend to run with. It would be foolish. If it ran, it would definitely get eaten. With the pairs, only 1 would get eaten. So you get a 50-50 chance. You don't have to be faster than the bear. You just have to be faster than your friend. But and I recognize that this is a very strange way to look at it. But I will tell you, this method was born out of frustration because I was trying to help my students understand how to simplify radicals, and everything I did in a traditional thread just didn't work. And so I thought outside the box, and that's where I got the bear. It was definitely outside the traditional math box. So let me just use a pretty color to emphasize whatever numbers don't have a best friend, an identical best friend to run with. Just wait in the cabin for the others to send help. Okay, once you've got that all written out, then it just remains to multiply. 5 times 3 is 15, times 2 is 30. So the square root, or the principal square root, or the positive square root, or even radical 1800 is 30 radical 2, which kind of makes sense because 30 squared is 900. So we don't quite get to 1800. So we need that little extra square root of 2 to get us there. Okay, so that's how you simplify a radical. Woohoo! Shall we move on? I know you're very excited. I can tell, even though I've pre-recorded this, I can feel through the monitor how excited you are. You ready? Dun dun dun! Now, this is a bad habit I have, is of doing my review and making sure everyone feels really comfortable, and then going ahead and like pulling out stuff like this. That's everyone's like, wait a minute, this is way harder than what we just did. And oh my goodness, I just noticed how much of a ghost impression. I need to buy better paper. So wow, that paper is wafer thin, isn't it? Okay, so I'll put the other pages over here and try not to lose them, so you don't have to look at them. Okay, now we can focus. So what I was saying is, whoa, these are really different. And the answer is they're not so much different. Basically, when we have other kinds of radicals, in this case, this is 3 is the index. It's called the index. You don't have to know this. I'm just telling you this because I have to know this. 3 is the index, and it means it's a cube root, which means we don't just have a square bear, we have a slightly larger bear. And I only have 1 puppet, so all I can do is I can say it's a slightly larger bear. See, I'm basically Peter Jackson making The Hobbit. Look at me using fancy camera techniques. It's a bigger bear because it's a cube root. So what does that mean? Well, what I'm going to do is I'm going to take 27 and I say, okay, that's 3 times 9, which is 3 times 3. A lot of 3s. My subconscious just really loves partying with 3s. So I write out 27 fully factored. And then my not square bear, but much larger cube bear now is out in the forest. These are stuck in the cabin and they're going to run. And when I take these guys, I need to take 3 of them running. And only 1 makes it out because it's a much larger bear. So 3 go running, 1 makes it out. Nobody is left in the cabin, so there's nothing inside, so it's just 3. The cube root of 27 is 3. Is this true? Is this correct? Let's check. 3, let me underline this guy. This is the 3 I'm talking about. 3, and then let me underline this. I know because I used a bunch of 3s and it's hard to know which 3 is which. So that 3 up there is this. Let's check. 3 to the 3rd power. Yep. Ah! Oh, I don't know where that came from. That was exciting. Sometimes my hand draws things. And it's just, you know, first thing in the morning and the coffee hasn't quite seeped into my hands yet. They're still a little sleepy. There we go. 27. Woohoo! Okay, let's try the next one. Now this one's an even bigger bear. So I'm going to have to use mega Peter Jackson camera techniques. It's a giant bear. It's a 4th root. So in this case, let me go ahead and rewrite this. I've got 4 times 4. Each of these is 2 times 2. So I've got the 4th root of 2 times 2 times 2 times 2. So 16, I broke it down, and 4 tells me how many of the numbers have to go running. So in this case, 4 of them have to go running. It's the whole thing. 1, 2, 3, 4. They all go running, and Mega Monster 4th root bear comes, and only 1 makes it out. And so that's the answer. I should box this one so it's clear. And then we can check by taking 2, which is the answer. Again, I'm going to make this one green so there's some continuity here. And I'll make my index purple. Two raised to the 4th power is in fact 16, and I am not sure where my calculator ran off to. Can you believe it? My calculator's sleeping on the job. So I'm going to have to show you a slightly different calculator. Same company, Texas Instruments, and you can see this one has been through it. It's been all scraped up. Calculators are awesome. They get through anything with you. And to check 2 to the 4th power on my calculator, that's 2. And then this one, rather than having an x to some power, I do have a dedicated square button right there. It has this guy. This button means exponent. It also means exponent on a keyboard. So if you're using like Google Calculator, or you just want to Google an answer, use this little caret, which is above the 6 on a traditional keyboard, will get you your exponent. And I'll go ahead and enter that. See, 2 to the 4th is 16. Woohoo! Yay! Okay, so let's bring us back down to the paper. Let's get rid of yet another bunny fur. Fun fact, when I am recording these videos, frequently there is a rabbit at my feet. The rabbit has a little den under my desk that he likes to hang out in. And sometimes he likes to sit right next to my feet while I'm recording. So you can just imagine these videos are coming to you via me plus my rabbit Chappie. Okay, so what fresh hell is this? This is what I was referring to when I said irrational exponent. So the base is 4. This is the exponent. I think I explained this in the previous video, but just in case I didn't, that's the base, that's the exponent. And when you have a rational exponent like this, what you end up with is 2 separate actions. So it turns out the numerator The numerator just means the top number on a fraction. This is the power. And this, the denominator, which reminds me of Phineas and Ferb. It's the denominator, but it's the one that denominates. This is going to be the root or the radical. Radical. There we go. Woo-hoo. Okay, so what the heck does that mean? Well, it means that there are two things happening here. I have both a radical and a power. So the base, whatever that main number is, goes inside. Now, the 3, which is the root or the radical, goes right there. And then the numerator goes up here as a power. Does that make sense? The top number becomes the power, the bottom number becomes the root. So this becomes the cube root of 4 squared, which is the cube root of 16. Kind of woohoo, kind of so far. And then we now know how to simplify that. So I'm going to take this and scooch it up just a little bit if I can. There you go. And then I'm going to say, okay, well, 16. And then I'm realizing, wait a minute, why did I multiply it out? I should have left it here because it's easier to figure out what's going on. But I'll just go ahead and quickly factor this and see that I've got the cube root of 2 times 2 times 2 times 2, 4 of them. Okay, so cube root means I've got a medium-sized large bear in the forest. So the cube root means 3 2s go running, and only 1 makes it out. And then this 2, which does not have any friends left, is going to wait in the cabin. Now, this is all very tricksy to write, and it's also not easy to input online for an answer. So definitely let me know if you're having any trouble inputting this, because it does take a little bit to figure out how to tell WebAssign what the answer is. So just let me know if you my train of thought derailed. So just let me know if you're struggling with that, because I do agree this is tricksy to write. Notice that when I'm writing it out, I do try to leave a little gap here so the 3 doesn't migrate down to join the 2 and become 23. This is 2 times the quantity, or 2 times the cube root of 2 is the best way to say it. Woohoo! Okay, there's page 2. And we're only, 3 hours into the video so far. So let's go ahead and throw caution to the wind and try one more page. How about that? Dun, dun, dun. Okay. So here is the thing. This particular class, which I'm writing this, which I've written this video for, is not one that's interested in so much in theory. This is interested in making sure that you're able to perform certain mathematical tasks. But every now and again, I'm going to nonetheless explain a little theory, because this answers questions people have asked me. So this page is completely theoretical, completely mathy, so we can geek out on the math. This is nothing I'm going to ask you on a test. So if you want, you feel free to, kind of soften your gaze and daydream about, I don't know, whatever it is you daydream about. But the rest of you are interested, let me leave you with a little geekery here. So a note about rational exponents. Officially, now notice this is a slightly different problem than the previous one. The previous one had 2 on top and 3 on the bottom. So officially, you're supposed to apply the numerator first. So what does that look like? So if I have the base 4 to the exponent 3 halves, then what I'm supposed to do is I'm supposed to take 4 cubed and then take the square root of that. Does that make sense? So 2 is the square root, 3 is the cube. And you're supposed to do 4 cubed inside. So what does that mean? Well, first off, I will make a note. I wrote the 2 here just so that you see where the 2 goes. But of course, if we've got 2 as an index, it just means the square root. So we really can just write it as this. Okay, so what is 4 cubed? Well, it turns out I happen to know this off the top of my head, that this is 64. Woohoo. And so I'm left with radical 64 or the square root of 64, which I'm hoping you know your times tables. If not, use your calculator and you'll get 8. And an additional little bit of geekery. When we're talking about radicals, we're always getting the positive answer out. We never get the negative unless there's a minus sign out in front. So if there's a minus sign out in front, that's how we get the negative. But otherwise, if there's no minus sign going into it, we always choose the positive square root. So 64, yes, has 2 square roots, but when you have a radical in front, you're saying, give me the positive one. Okay, so this is the official way you're supposed to do this. However, if these numbers you're working with exist, so in other words, we don't have something where we've got a square root of a negative, which is always a complicated situation. So if we're not dealing with i's or imaginary numbers, if you've studied those, then it turns out that if we have 4 to the 3 halves, we're actually allowed to do it kind of backwards, inside out. You are allowed to take the square root of 4, take the square root first, and then cube it. Now, why is this helpful? Well, and here I'm writing out more steps than you need to, just to be very clear. You don't need to write all these steps out. But the nice thing about this is that in this case, I take the square root of 4, which is hopefully familiar, is 2. And then I cube 2, which is 2 times 2 times 2, which is 8. So I am getting, let me see if this will all fit in one screen. Oh my goodness, look at how lucky we got. So notice that I got the same answer. But I worked it out in 2 different ways. One was to go ahead and make the number bigger and then shrink it down. And one way was to shrink it down and then make it bigger. And personally, I think this is almost always going to be easier. And so what I'm telling you is that for the problems we'll have in this class, you can always reverse the order. Even though officially you're supposed to take the power and then the radical or then the root, I'm saying go ahead and take the root first. With the problems we're working with, you won't get a different answer. Woohoo! You guys are awesome. You made it through yet another video about math. Woohoo! Pat yourselves on the head and go get yourself something lovely to eat. Maybe some vegetables, some water, get some exercise, maybe a little rest. A nap is nice. Give your brain a rest from both the computer and from math. Maybe do some art or dance around or make some music or, just go outside and scream into the existential void. Whatever it is that helps you get through your days, you guys are awesome. And, I'll see you in the very next video. We'll continue on with 0.4. I know you guys are so excited. So, woohoo and math on.